Hey guys, let's start with a couple of housekeeping reminders. It looks like we are going to be online for the rest of the semester. That means your next test and your final exam will both be online assessments. So I am looking into what we are going to do about those items. Also, I will be putting each lesson up as I would teach it in class. And then I will be available during your class time for Q&A every evening that we would have had class, that is. Okay, so let's get back to 3.5 optimization. We were talking about this last Wednesday, I believe, which was our last day of class. Sorry, trying to minimize this. All right, so if you go to your notes section, you should be able to see these notes. They're labeled as 3.5, and you can get all of these notes there. We did talk a little bit about these items last class. So we want to make sure that we're reading through the problem, we're listing out the variables, noting our units of measure, etc. We are translating the problem into the quantity to be maximized or minimized. That could be profit, volume, area, whatever the question may be. Okay, and then we are trying to express everything in terms of one variable. Okay, so we have a thin piece of cardboard. It is 8 inches by 8 inches, and we are cutting out square corners here. Okay, we're cutting out square corners. That's what makes it fold up nice. You'll notice that each of the sides here, when I fold that up, that's going to be a side, is going to be X units long. And you can see that also over in the picture here. Okay, so what dimensions will yield the box of maximum volume, and then what is that volume? That's what we need to find out. Okay, so let's see what we can do here. I'm going to scroll this down a little, see how much of this we can get on the page. All right, so the thing that we want to maximize is volume. Now this is a box, so remember I said to start with most general terms. Volume is length times width times height. Okay? So we want to define each of these things in terms of one variable. So our height, that's that section that we're going to fold up, that's X. If the box starts out 8 inches wide, okay, I have to fold up X on one side and X on the other side. That is folding up 2 X's. So my width is going to be the 8 inches that it started out minus 2 X's. There's 1 X on this side and 1 X on this side. So 8 minus 1 X, 2 X. My length will be the same thing because this was a square. So 8 minus 2x. So now I have my general volume formula, and I have length, width, and height all in terms of x. So we're going to go ahead and fill that in. Volume equals length, 8 minus 2x, width, 8 minus 2x, and my height, which is x. Okay, let's go ahead and multiply that together. So that will be volume equals 8 times 8 is 64. We have to multiply 2 of them together, and then we'll come back and do the other 2. Minus 16x minus 16x, so that'll be minus 32x. And then plus 4x squared. We still need to multiply all of that by x. So that will be 64x minus 32x squared plus 4x cubed. Okay, and then I want to rewrite that so that it is in standard order. So we have 4x cubed minus 32x squared plus 64x. Okay, If we want to maximize volume, that means we're going to need to take a derivative, which is v prime. So we're going to have 12x squared minus 64x plus 64. Okay, this is a quadratic equation, meaning it's an x squared. It exists everywhere, so we don't have any relative max or mins from where it does not exist. So we want to set this whole thing equal to 0 and solve. The first thing that I see, I like to make these numbers as small as possible, is that everything up here is divisible by 4. So I'm going to divide everything by 4. 4, 4, and 4. And I get 3x squared minus 16x plus 16 equals 0. Okay, 3 times 16, so that's 48. I'm just doing the work to figure out how to factor this. We have to add to a negative 16. So I think that that is going to be negative 12 and negative 4. We're going to divide each by 3. If you don't know what I'm doing on the side there, you need to look that up. That would be the bottoms up form of factoring. It would be on YouTube somewhere. That's something that you should have learned in college algebra, is how to factor things with a leading coefficient larger than 1. Okay, so we need to simplify this. 1 and negative 4. Okay, so we get 3x minus 4, x minus 4 equals 0. Those are our factors, which are going to solve to x equals positive 4/3, and x equals 4. Okay, I want to pause for 1 minute. I want you to pick up a piece of paper. Usually I would do this in front of you in class to demonstrate this. But I want you to grab a sheet of paper that is 8 inches. Okay, if I don't fold anything up at all, so if x is 0, remember x is our height, x is 0, do I have a box? The answer there would be no. So we need to talk about our domain. Our domain has to be bigger than 0. Okay, let's think about this one more time. If you take an 8-inch paper and you fold it exactly in half, I want you to go ahead and do that. Okay, if you fold it in half, it was 8 inches to start, you fold it in half. How much did you fold on each side? And the answer there would be 4. But if I fold it all the way in half, it is flat. The bottom of the box will have no width to it. So I have to have something less than 4. I can't include 4 because I wouldn't have the bottom of the box. That means 4 cannot be a solution. So our only solution is that x is 4/3 or 1.33. And those were inches. Okay, that's the dimension of x. Now, if you look back at the original question asked us what the dimensions are. This is our height. Our width was 8 minus 2x. We're going to plug in 1.33 in for the x. So 8 minus 2 times 1.33 gives us 5.34. And our length will be the same, which is 5.34. Okay, we also wanted to know what that maximum volume was. So our maximum volume, I would take our length, our width, 3/4, and our height, and multiply them together. Let's see what we get. And we should have gotten 37.93 inches cubed. Don't forget to label. Okay, remember I will be available every Monday and Wednesday night during your class time for questions, because I know this unit is a little difficult. Okay. is the other example. Now, we did this last week on Wednesday, but I just want to go back over it. We had the stereo manufacturer. We need to find total revenue. Remember, revenue is price times quantity. So for this one, R of X equals 1,000 minus X, and our quantity is X. So R of X equals 1,000 X minus X squared. Okay, that's part A. Part B is to find our profit function. Go back up here. Okay, remember, profit is R of X minus C of X. Okay, so R of X was 1,000 X minus X squared minus C of X is 3,000. And this slide was wrong. That should say 20X plus 20X. Now, why did I put that in parentheses? Because I have to remember to distribute this negative. It will change both signs of the thing coming after it, the expression that I am subtracting. So we get that P of X is 1,000 X minus X squared minus 3,000 minus 20X, which means that P of X is 980X minus X squared minus 3,000. Okay, part C asks us how many units we need to make in order to maximize profit. That means we are going to take the derivative of profit. So we get 980 minus 2x. Again, that function exists everywhere, so we're just going to go ahead and set it equal to 0 and solve. We get 980 equals 2x, which means x equals 490 units. I think these were stereo, so you could have labeled it with that as well. Okay. Do we know for sure this is really a max? Well, let's check. In our second derivative, if we check the concavity, we'll know if it's a max. So our second derivative is -2. That tells me that this is concave down, meaning it's like this, which means that our point is up here at the top. Therefore, it is a max. All right, part D. We have to plug this 490 into our original profit function, not the derivative of the profit function. So plug this in, 980 times 490 minus 490 squared minus 3,000. Let's see what that gives us. And we should have gotten 237,100. And part E, use the price function that was given to us, lowercase p of x, that was 1,000 minus x. So when we plug into that, we have lowercase p of 490 is 1,000 minus 510. I'm sorry, minus 490, getting ahead of myself, which is 510. So $510 is the price that we are going to charge. All right, let's go back up here. 1 second. Okay, back up here, I want to add to these notes just a little. So what is our maximum profit? Plug into original P of X. This one would be find critical values. And this one would be plug into price function P of X, lowercase p of X. All right, that is all for today. I will go over any questions you have, look over any problems that have maximum area or other types of things that are in the homework, and let me know if you have questions. I will see you, or hear from you rather, on Wednesday night. That's all for now.